Hey everyone, Carlos Australia from Cadgroup here. I think we'll be starting in a couple of minutes. Thanks for those who signed in early. Let's just give others a couple of minutes to log in and then we shall start. All right, let's make a start. Once again, good day everyone. My name is Carlos Australia. I'm the National Technical Manager for Cadgroup Australia. Just as a brief intro, I think I've been doing quite a bit of these webinars. I've been with Cadgroup for more than 10 years now, but I've also been a Inventor and Vault user for about 20 years, 20 or more years now. And today I'm hoping to show you some of the techniques that are used to manage top-down designs in Vault and Inventor. The next should take us about 40 minutes, and then I'll leave some time for Q&A after. But at any point in time, please feel free to just raise your hand or raise your virtual hand and the GoToMeeting interface, or GoToWebinar interface, and I'm happy to answer the questions then and there. So today, what we're going to be looking at is basically what is top-down design methodology. And this is purely from an inventor perspective. I'm hoping you are already using top-down design methodology because this is a really effective way to model, especially when you've got a lot of interrelated parts in your models and you want to make sure and you want to control this a bit easier. So we'll talk about top-down design methodology. Then we'll talk about how Vault revisioning works, because this is where some people get tripped up when you're using top-down design methodology and using Vault revisioning. Now, when you talk about Vault revisioning, this means that you're most probably using Vault Workgroup or Vault Professional. Vault Basic does not have a revisioning mechanism. It has a versioning mechanism, which we will also discuss what that means, what the difference between versioning and revisioning. But basically, when we talk about revisioning, this is just for Vault Professional or Vault Workgroup. Now, in case you're not aware, Vault Workgroup has actually been slated for end of life. And over the next couple of years, you're no longer, in fact, Vault Workgroup 2023, if I'm not mistaken, is the last edition of Vault Workgroup. You will need to upgrade to Vault Professional very soon. And if you're in this situation, please feel free to contact us, Cadgroup, or your account manager from Cadgroup, and we can help you out. Now, whenever you're combining top-down design and Vault revisioning, I wouldn't say strange things happen, but it's better for us to get an understanding of what is actually happening when you're trying to manage top-down designs inside Vault. Because sometimes there are some dialogues that Vault present and you're wondering, why can't I release or approve this file? It's something's preventing files from getting approved. But we'll have a look at why that's happening. Lastly, we'll have a look at some techniques that we use to manage top-down designs in Inventor and in Vault. So what are some best practices when it comes to Inventor and particularly Vault when we talk about top-down modeling? All right, now let's talk about top-down design. Now, it's a technique also known as skeletal modeling. It's also known as master part method or master sketch method. But what this means is that with top-down design or top-down modeling, this allows you to centralize the control of your design. So effectively, you're trying to control your design just within one component, and then that single component can drive multiple components in your assembly. So that way, when you're controlling just one component, everything else effectively starts to fall into place, starts to move. Now, there are really two ways that top-down design works, right? Or two methods, okay? So it begins with a top-down design will always begin with either a master part or a master sketch. Again, as I mentioned, in the industry, there's several kinds of methodologies or terminologies that are in play here. The top-down design technique, as I mentioned earlier, is usually known as skeletal modeling. Some people will refer to it as a master sketch method or as a master part method. Now, for this particular webinar, just to, I guess, have a common ground of terminologies, when we talk about a master sketch, we create a sketch, a top-level sketch that represents components in your assembly or your sub-assembly or your floor plan or equivalent. And each group of sketch elements can represent a specific component. Now, in a master part, you create a multi-body part file, and then each body then represents a component in your assembly. So just to, I guess, put some more meat into that, let me just open up Inventor here. And I'm going to open up two things. I'm first going to open up, let's say, a master sketch. Let's do a master sketch first, because that's what I did first in my presentation. Let's have a look. I'm just making sure that I'm seeing, yep, okay. So if we look at the master sketch here, for example, this is effectively a very simple master sketch. And I guess one tip I can give you straight away is that you want to try and make your sketches simple or breaking down your master sketch broken down into multiple sketches. It's very hard for, or it causes some performance issues in Inventor when you have a single sketch file that's got hundreds and thousands of components and geometry there. So you want to try and break it down. Now, this is what we call a master sketch, where you've got just one sketch file. And this particular master sketch is a master sketch of 3 plates. I've got one rectangular plate here. I've got one sort of square plate here. And thirdly, I've got a triangular plate here. So if you imagine, this master sketch represents an assembly of 3 plates, right? And all of that is controlled through the dimensions of this single master sketch. Now, if I have a look at a different kind, which is what we call our master part method, or yep, let me call it this, open this master part here. So this master part, as you can see, it's 3D geometry, right? Master sketch is the same thing, but the master part method basically includes solid bodies. So if I have a look over here, I've got multiple solid bodies over here. And if I expand that, I've got a plate, I've got a main bush, I've got a top bush, and I've got a bottom bush, right? So this particular master part has 4 solid bodies. And what we would do later is this particular master part, I can then extract this so that it's actually creating, or I can actually create multiple part files from these individual bodies, and also an assembly that holds all of those part files. So those are the 2 main differences between a master sketch and a master part. Now, in real life usage scenarios, master part or master sketch. I see a lot of times master sketch method is used when you've got, for example, you're trying to model a big structure or of structural steel or chutes or things like that, right? So that's when I typically see a master sketch method. In a master part method, if you've got, let's say, an assembly of mechanical components that are usually welded together, of a smaller scale, not too many components in that particular master part, then that's when a master part or method is used. Right, let's go back to the PowerPoint slide. Okay, so these are the two main topologies that we'll be looking at today. So if we have a closer look at the master part method, I've just diagrammed this in this diagram over here. So from a single master part, right, like similar to what we had here earlier in Inventor, you have a single master part, right? It's a single part file with multiple solid bodies. Then you use Inventor's make components command, and what that does is it actually derives all of these components, right, from that master part. So each solid body becomes a single part file. And then that same command will also place all of those components into the assembly itself. So what that looks like if I bring that into Vault is that I've got, let's say, the swivel assembly as the top level assembly. It has the bottom bushing, the main bushing, the plate, and the top bushing, or the top bush. Now, all of those bushes, or in fact, all of those components are actually using the master part.ibt. If you notice in Vault, I'm in the Uses tab inside Vault. So I can see that swivel assembly uses bottom bush uses master part. All right. So the way this works inside Inventor, in fact, let me just save this component here as another component. Let me create another folder. Bear with me for a second. Let me just structure this out. I'm just creating a new folder. Oops, let me go here. Because I'm using Vault Data Standard, it controls what particular folders I can use. So I'm just going to create a new folder inside here. Okay, and that's going to make it available inside my Inventor interface. So top-down methodology, MP03, and I'll just call this master part 03. Okay, so I've got master part 03. That's great. Now, if I do a file, and if I do inside Inventor go manage, and I go make components, so I can then choose solid bodies. Let's say I'll choose all of the solid bodies. I'll put it into master assembly. I'll make sure I'm using the right template. I'm going to use a metric one. I'm going to make sure it goes to the right folder. So under demonstration, top down MP03, master part 0, master assembly. Let's call this assem, if I can spell this correctly, assembly 03. Next, all of those have been selected. That's great. And click OK. Yep, these are just some file conflicts that I've got in my template that I haven't updated to 2024. I'm only now starting to use 2024 in full anger. But as you can see here, it created that master assembly 03, and it's created individual part files, right, for those solid bodies, and it's actually grounded those individual part files in those solid bodies. All right. So that's grounded that as we expect. So now if I save this, let me save this again in that demonstration folder, MP03. Yep, bottom bush, yep, top bush, MP03, yep, plate. Okay, and it's just checking all of these inside Vault as well. So if we look at inside Vault, I should refresh this and I should see those components there. And if you look at, for example, master assembly 03, if I look at the subcomponents and if I look at each one of these, they're all referencing master part 03, right? So that's one method of creating a master part. Let me just change my view to shaded with edges. And basically now they're all inside Vault. Okay, now let me create another one so I can show you what happens. So that's what happens when we look at a master part modeling method. We use the make components, we make individual parts, or the make component command makes those individual parts, and then it automatically creates that assembly. Now, if we have a look at the other method, which is the master sketch method, what happens is I've got a master sketch. From that master sketch, I use the derive command to create individual parts, or rather I should say, I create a part file, and then I use the derive command to derive the master sketch into that part file. And then when I create an assembly, I can then place the component into that assembly, and also I'll place although not necessary, I should say, but I can also place my master sketch into that assembly. And I'll show you one of the reasons why you may want to do this. Now, the way the Inventor structure or Vault structure of this looks like is almost exactly the same. You now have that top level assembly. Each component, I should say, references the master sketch. The top level assembly also references the master sketch. So how does that actually look like? So let's go inside here. In fact, let me go back into Vault first. I'm going to create my standard folder. I'm going to call this MS03. So I can go back into Inventor. I'll open up my master sketch. I'll save this as master sketch 03 in my demonstration, top-down methodology, MS03. I'll call this master sketch 03. Okay, now let me just make some mods to this particular sketch here before, yep, there we go. And I just want to make sure that this is a driven dimension. Oops, no, not that one. Driven dimension. I'll make this a driving dimension. And so, yeah, effectively, I can change the angle of this. Great. Wunderbar. Okay, now let me just change how I am actually deleting or creating these, because I actually want to project my origin. This is just some cleanup I'm doing for this particular master sketch. Oops. Okay, so I've got a master sketch here, right? So this master sketch, for example, again, is a representation of an assembly that I want that's got 3 plates in there. Okay, so what I'd do is I'd save this. Fine. Now, if I create a new part file, I'm going to use under manage, I'm going to use my derive command, and I'm going to derive that master sketch that we have here. Okay, and make sure that I'm deriving that particular sketch that I want for this particular model. Okay, so yep, it's not checked out. That's fine. So from here, I can use my 3D modeling commands. I'm just going to extrude this 10 mil. Great, that's 1 plate. So I'm going to call this, for example, demonstration top-down plate 03-01. Okay. And then I'm going to do the same again for plate 2. Manage derived groups. No, not that one. Derived components. This is what a bit irritating that we still have to go back to that main one. But that's been derived. Again, because it's been derived, I can now extrude. I can extrude that, and then I can save this. And I can save this in demonstration, top-down methodology, MS03. And we'll call this plate 03-02. And lastly, we've got another one. Let's do the third and last plate where we're managing it. deriving again the top-down with MS03, master sketch 03. Yep, extruding this triangle over here, saving. Plate 03-03. Okay, I've got those 3 plates now. And what I can then do is I can create an assembly. And I can then place into that assembly, I can place my master sketch. And the reason I'm doing this is so that when I start placing my individual components, right, that's that one here, I can use that geometry that I've used or that I have in my model to actually constrain all of these components. Now, you could also do a place and grounded, and that will actually fix everything for you. That's easy. But if you're expecting that there's going to be some movement in your particular assembly, then I would suggest just using the the constraints. But again, it depends on how much movement and how much resizing you're going to be doing. So let me just go this one lastly. Excellent. Okay. So now let me just turn on my edges again, just so that we can see those edges. So I've got now that master's sketch. I've got those plates. Ooh, let me save this. And again, in that demonstration, top down, let's call this master AC03. Yep. And it's now going to prompt me to check this into Vault. That's great. If I now look inside my Vault, if I refresh this, I've got master assembly 03. If I look at, I've got that master sketch, and under each component of that master sketch, I've got that there. Now, again, one of the wonderful reasons why we might want to go to a master sketch method or a master part method is when we talk about modifications. So, for example, yep, that's. Let me just close all of these down to make it more. Okay. So, for example, here, if I knew that this angle here needed to be changed, right? I can simply, instead of going to individual components, I can simply open up my master sketch. I can edit that sketch, and maybe I'll say this is now 50 degrees, right? Okay, yep, check it out. Yep, so that's now more right triangle, 50 degrees. I save that. Now my master assembly, as you can see here, it's now going to want to update each and every component. So if I go a global update, then effectively I've controlled everything just through that one sketch. Now, obviously, I just made one small change, but I could have also changed the height, so on and so forth. Instead of opening up multiple components, all I need to do is open up just one component here. So, for example, this one, if I want to make this 400, and I'm wanting to make this 120, right? I save that. That's my master sketch. Again, I go to my master assembly. I update everything. Everything is updated just based on that master sketch. That's all nice. It's all good. In fact, let's now check this into Vault. So that's one of the driving reasons you might want to go to a master part or master sketch method. Again, it's a lot easier to make modifications in that level. Now, where does it become a bit more difficult when we talk about Vault? I wouldn't say it's difficult. We just need to understand what's happening and what Vault is trying to do. Now, when we talk about Vault versions and revisions, okay, versions are incremental changes to a file. So anytime you check a file into Vault, that's an incremental change, then it creates a new version. Technically speaking, it's when you check out the file, Vault creates a placeholder version, and then when you check it in, it then consumes that placeholder version. But, you know, long story short, whenever you make a change, check out and check into a file, that's a new version inside Vault. Revisions are milestones in a file's life cycle. So what happens in a milestone is that you're actually recording, okay, this is a very specific kind of state of my file. And when you combine this with Vault's lifecycle mechanism, which are your lifecycle states, then you can come up with, for a single file, you can have a situation where that single file is 8 different versions. Out of those 8 versions, they are covered over 2 revisions, Rev 0 and Rev 1. So, for example, the file was first created at version 1, at revision 0, at an initial check-in. Then, after checking it in initially, you needed to make some changes. So that's made a new version. You checked out the file, you checked it back in. Now that's version 2, still at the same revision. It's been submitted for review. Now it becomes version 3, right? And it's now still at revision 0. It's been submitted for review. It's passed review. It's been approved for manufacturing. So it's now in version 4, revision 0, still at revision 0, and then it's been released to manufacturing. Now, one of the very standard mechanisms of Vault is whenever you release something for manufacturing, right? And then this is now locked down, nobody can make any modifications. If you want to make modifications to this, then you'll have to bump it back from released to work in progress. That makes version 5, but then it also bumps up the revision to Rev 0. Okay, so somebody's made a comment that when they transitioned it back to work in progress, it's because changes were needed to suit the top bracket. And then you have the whole process repeating again until it's been released at revision 1. Okay, so that's for one single file. Now, what Vault also does is that in order to release a parent, right? In order to release a parent, and when we talk about parent, for example, Master 03 is a parent, Master Sketch 03 is a child, right? So in order to release a parent, the child must also be released either beforehand or in that same process. This makes perfect sense because you don't want to approve an assembly or release an assembly for manufacture when one of the parts of that assembly might change, right? Because you might be approving this assembly, it works this way, and then somebody then goes change a part. You may want to make sure that that part does not affect that assembly at that point you're reviewing it. And so Vault, by default, has that check that in order, when a parent is released, all of the children components must be released as well. Now, another nuance of Vault is that it will always try, or Inventor and Vault will always try to consume the latest revision and the latest version of a non-released file, right? Now, what does this mean? It means that whenever you open up an assembly and it's in a non-released state, okay, whenever you open up an assembly and it's in a non-released state, I should state that clearly, it'll always try to consume the components or the children, the latest versions of those children, right? And that makes sense because you want to make sure that the assembly, while it's in work in progress state, it's always referring to that latest version of a file. Now, Vault will also do a snapshot on release. So when you put it to a released state, now it may be called, the state itself may be called released, or it could be issued for construction, issued for manufacture, as built, or whatever you'd note. But effectively, whenever, let's have a look at a particular component here. Whenever something is released, right, state name is called released. But in reality, what Vault is looking at, because this state can be named issued for construction, it can be named issued for manufacture, there is a metadata flag of Vault that says, is it a released revision? And it says true. That's what it means to say that that's now the latest revision of that file that's been released. Okay, so it's at a release state. Now, when it's at that release state, okay, what Vault does, and let me have a look at this one here. Yeah, so for example, here, when we have a look at this file at revision 2, that's a top level assembly at revision 2 released. If I now expand that, that's released. If I expand this, it's saying revision 2 of the assembly is using revision 1 of the bottom bush, rev 0 of main bush, rev 0 of plate, and rev 1 of top bush. That's when it was released at revision 2. When it was first released at revision 1, it was using a totally different set of revisions of files, right? It was using bottom bush at rev 0, main bush at rev 0, and plate at rev 0, top bush at rev 1. And obviously, if you expand that, it will also tell you those master components or master sketches that were used. So when it was initially released at rev 0, everything was at rev 0, which makes sense because when you start releasing an assembly, you may not want to roll up the revs every time you release a single component in that assembly. Okay, so where does this become a little bit more complicated when we talk about Vault, right? So let's have a look at an example here. I'm going to say release the top level assembly. I'm going to go change state. I want to say go ahead and release this one here. Everything's been released. That's great. Wonderful. Right? All of the components have been released. Right? Now, for example, I've got a situation where, hey, I want to make a change to plate number 3. Okay? I want to make a change to plate number 3. Now, if I make a change to plate number 3, I'm going to go change state. Okay, and I'm going to say that, okay, when plate 3 is released, master sketch 03 is released, obviously. If I bump this up back to work in progress, right, I want to also change master sketch 03. Okay, so now that's work in progress. We're both now back at rev 1. And obviously, because plate 3, I'm going to make a dimensional change, I also want master assembly 03 to change state as well. And this is where, and I'll explain that later, but basically, master assembly 03 is now at revision 1. Now let's go back into Inventor and let me just refresh all of this. Let's do a refresh file. And you'll notice those rev triangles have appeared because the last time I opened this file in Vault, or sorry, in Inventor, it was at rev 0, but at a work in progress state. Now it's at released revision 0. So let me just do a get revision, and it's now at work in progress in rev 1. So that's fine. Okay. Now let's see if I want to make a change to master sketch 03 here, because that's what I want to do. I wanted plate 3, which is this one. I wanted to make a change to that. Let's say I want to make this 80 degrees. I want to make it much shorter. So I'm going to check it out. That's fine. It's much shorter plate now. That's fine. And I look at this assembly here. You'll notice that it will want to refresh everything. You'll notice that there's a refresh symbol against each and every plate, which makes sense because all of these actually use that particular component, right? Use the master sketch. Now, a lot of times, this is where the confusion happens. Why are these components requiring a refresh? I only changed plate 3, right? I only changed the dimensions referring to plate 3. And yes, you're absolutely right. You've only changed the dimensions referring to plate 3. But because plate 1 and plate 2 are referencing the same master sketch, from their perspective, they don't really care. Plate 1, plate 3 and plate 2, plate 1 and plate 2, they don't really care. Although physically nothing has changed in those plates, because they're still referring to that same sketch, that's why it's asking for an update. So if we update this now, okay, it's saying master assembly 3 is not checked out. Yes, I want to check it out. Yep, that's fine. So plate 1 is locked because it's been released. Do you want to edit anyway? Yes. Plate 2 is also locked because it's released. Do you want to edit anyway? Yes. Plate 3 is not checked out. yes, I want to check this out. I know that this needs to change. So that's now been changed. If I look at my Vault 3 here, I'll notice that I've got a whole bunch of stuff here that's saved, right? If I now try and save this, okay, and now I try to check this in, it's fine. It allows me to check everything in, and that's great. But what you'll notice now inside Vault, okay, so this has been released. If I now try to release, for example, change state, if I now try to release master assembly 3, which I do want to do that, I want to release this master sketch because yes, I've made a change to that. I want to release plate 3, yes, I want, because I made a change to that. That's fine. However, you might see the, or you will see this particular restriction. One or more restrictions were found for the change state operation. And it's showing actually as a clue here. There's a rev triangle here that says that the file is not the latest. Okay, in fact, if I click on this button here, one or more restrictions were found. I go details, and it says master sketch 03 is not the latest. Okay, why is that? Right now, if you understood what happened, you're absolutely right to assume that it's thinking that the master sketch 03 associated to plate 1, okay, because there's been a change here, plate 1 is still looking at the older revision of master sketch 03. So let me show you this. If I look at plate 301, if I look at, let's say, when it was released, it's using master sketch 03 at rev 0. Okay, plate 301 is using master sketch 03 at rev 0. If I look at the latest here, you'll see that now the latest condition of plate 301 is that it's now related to, or can possibly be linked to master sketch 03. Okay, sorry, at master sketch 03 at revision 1. I'm hoping that's making a bit of sense. So if I just have a look at, for example, going back to my PowerPoint slides here. So initially we had the assembly at rev 1, everything was at rev 1. We needed to make a change to just one component. We just needed to make a change to part 1. Okay, because we're making a change to part 1, rev 2, we had to make a change to the master part at rev and made that rev 2. Because you made that change to part 1, made it rev 2. Assembly is now at rev, needs to be at rev 2. Drawing needs to be at rev 2. Now, technically speaking, we did not make any physical changes to part 2 or part 3. So they can still stay at rev 1. Okay, let me repeat that. Although we changed master part file, made it rev 2, so that we can make a change to part 1 and made it rev 2. When we made a change to the master part file, we did not make any changes to the parts of the sketch that actually make or affects part 2 and part 3. They can still stay at rev 1. Okay, but obviously because part 1 affects assembly 1, this one had to go to rev 2, and therefore also the drawing had to go to rev 2. That is what is happening here. Okay, so if we go back to Vault here, the latest condition of this file of plate 3 is that it can be linked to rev 1 of the master sketch, but at the time the plate was released at rev 0, it was linked at rev 0 of the master sketch. And that is why when you go change state here and you want to try and release all of these, it's showing you that restrictions and those rev triangles, and if you hover over it, this file is not the latest. So this is just Vault trying to tell you that, hey, are you sure you want to release plate 3? Sorry, not plate 3. Are you sure you want to release plate 1? Because there is a newer revision of master sketch. Okay, so it's Vault simply doing its job. It's trying to tell you that a change has been made to the master sketch. It's your decision now whether you want to go ahead and release plate 1, right? Still referencing master sketch at rev 1, okay? Or sorry, at rev 0. So it's really important. In fact, let's do this. Let's add all version revision. So you'll notice here, for example, it says here, master sketch here is at revision 1. That's the one that's being referenced in plate 3. Master sketch is at revision 1 as well. That's what's being referenced by master assembly. But the master sketch at revision 0 is being referenced by plate 2 at revision 0, and plate 1 is referencing master sketch at revision 0. So I hope this makes the explanation of why this is happening or why this is appearing a bit clearer. Again, it's simply Vault telling you, are you sure? Are you sure you want to release plate 1 while it's still referencing master sketch 03 at its initial revision? And that is all on the designer to make sure that, yes, I do want to release that. And this will actually allow you to go ahead and release this particular file. So it might say 1 or more restrictions were found for the change state operation. Do you want to continue changing the remaining objects? If you look at the details, it's saying master sketch 03. And when it's saying master sketch 03 file is not the latest, it's referring to these entities or entries for master sketch 03. It's not the latest revision. Admittedly, there should have been more clear in its terminologies, but the only file that's not the latest is master sketch that's associated to plate 1 and master sketch that's associated to plate 2. Let's click yes, and that's now effectively released. And you can see here, if I look at master assembly 03, if I look at the latest of this, I can see that master sketch is at rev 1, plate 3 is referring to master sketch at rev 1, plate 2 is referring to master sketch at plate 1 because again that's the release. Plate 1 is referring to master sketch at rev 1, but if we have a look at when it's actually released at this current state, you will notice that plate 1 is referencing master sketch at rev 0, plate 2 is referencing master sketch at rev 0, plate 3 is referencing master sketch at rev 1. So that is what is happening in our Vault environment, and that is effectively the reason why there's a bit of, I guess, confusion or difficulty. It's because when a change in a master part is made to a master part or sketch, right, it requires, okay, in fact, maybe I should rephrase this. It reminds us that all those parts using that master part or sketch, and consequently any drawings and assemblies, need to be updated to use that master part or sketch. Okay, this means that even if the change to the master part or sketch affects only a single component, all of the components will also need to change, right? So this is where it can get a bit tricky, because normally what people would do in the past is, let's say again, it's only plate 3 that needed to be changed. Okay, it's only plate 3 that needed to be changed. In fact, you know what? Let's do this. So in the past, what would happen is if only plate 3 needed to be changed, then what would happen is that go here, you go change it at top level, you bump everything back into work in progress, right? Everything now is at work in progress, right? Obviously, these files cannot go back into work in progress. So everything now is in work in progress. And what needs to happen now is that if I go back to Inventor, let me refresh this. Let me refresh the file and let's get the latest revision. What you're effectively doing is you're effectively telling Vault, right, that you want to make sure that each and every one of these components are actually using the master sketch at rev 2, the master sketch at rev 2. So effectively what this would mean is that you would need to have opened up each and every one of these components to make sure that they're referencing the master component at that particular rev. You need to check it out and then check it back in. So obviously that's not an ideal scenario, because if you've got a master sketch that controls 100 different components, master sketches can do that, then you're going to end up, just by making a single revision, you're going to end up needing to open up each and every component of that just so that you can check it out, associate that latest revision of the master sketch to the part, and then check it back in. Okay, so now everything's been checked out. In this case, I only have 3, so it was quite easy. Let me check this out as well, top level. Any questions? No questions, okay. And let me check this back in. So what you'll see now inside Vault is that master sketch Unity work in progress at Rev 2. If I expand all, you'll notice it's using, if I go to latest, it's using all the latest revisions of the master sketch and all of the parts. And then I can easily now go change state of this and bring everything to, let's say, a release state. Okay, so I hope that makes a bit more sense in what is happening whenever Vault tries to warn you that some files are not the latest. It's simply a warning. You can still go ahead and do a change state, but again, the onus is always back to the designer. The control is back to us as a designer to make sure that, okay, I am using the latest master part or master sketch for this assembly. So how does this actually work? Now, ideally, yes, you would want to make sure that you're always using the latest revision of the master sketch in all of your components. Now, it's all up to you. How do you want to control your revisions inside Vault? And that is where I'm just going to go back here from this slide here. We're talking about this. So what are some tips that I can offer in this particular scenario? So whenever you do a change state inside Vault, make sure that you're aware of what is changing, okay? Because Vault is trying to help you make sure that the correct files are being used. So Vault will only will basically make sure or warn you at the very least that the correct file is being used. So if you make a change to master sketch, right, 03, or if I again go back to our example earlier, if we make a change to the master sketch and we don't change plate 1 and plate 2, just make sure that you really don't make any changes to plate 1 and plate 2. Again, the onus is on the designer. Now, one way to get around this kind of provision is to break down your master sketch or master part into sub-master part or sketches. Now, what this effectively means is that although we have one single master sketch here, right, controlling this geometry, this geometry, this geometry, if I broke this down such that I have one master sketch referring to maybe these 2 components, and another part file as a master sketch referring to this component, that effectively means I'm breaking the chain. I'm subdividing what needs to change whenever I need to make a change, right? I don't need to just rely on one part. Now, obviously, somehow that kind of makes the master part method a bit more difficult, if I can put it that way, because ideally you just have one master sketch, but again, depends on the level of resolution you want to control your revisions at. So yes, you can break down the master sketch into sub parts. Now, another tip I can give you is that whenever you're working on a master part or master sketch method, try and release the master part or master sketch first before everything else. That way, all of the components that you are now using to reference that master part or master sketch, right, is effectively going to get consumed. So even if it's your very first revision of that file, let's say you want to make a change to the master sketch, change the master sketch, bump it back to work in progress, bump the rev of the master sketch, change the master sketch, and then release it. After you release the master sketch, that's when you start opening up the subcomponents, like in our case, plate 1, plate 2, plate 3, opening them up and checking them out and making the changes. So that's one tip I can give you. It makes Vault and Inventor work much smoother. So yep, these are the main things that I wanted to cover. How are we doing for time? Yep, I think we should be okay for time. Yeah, I just want to open up the floor to any questions. Yep, I'm happy to unmute everyone, or if you've got a question on the chat window, please go ahead and unmute. So yes, I'll unmute all of the attendees. Yep. Or if you want, just type something into the chat in the questions window or in the chat window. Happy to answer it there. All right, I don't think I'm seeing any questions pop up. Nobody's unmuted themselves. All right, well, if that's the case, thank you very much, everyone. Thank you very much for attending today's webinar. I hope you found it handy. I hope you found it enlightening when you're dealing with top-down methodology modeling inside Inventor and Vault. I hope it clarifies some of the things that a lot of people ask with regards to why can't I release the file? That's the most common question we get. And yeah, again, thank you very much for your time. Have a great day ahead.